Hey there, glad you're here. Curiosity hits different around here. This is where science, history, and the universe collide in the best possible way. A pulse of neon threads everything together for a second. Okay, let's open today's unexpected door. What if I told you the weather above your head might already be slightly human influenced? Not in a sci-fi villain with a control panel way, but quietly, carefully, experimentally. Today, we're stepping into a strange middle ground, where science meets clouds, lasers point at the sky, and rain becomes negotiable. This isn't conspiracy. This is climate engineering as it actually exists. And by the end of this video, you'll know what we can do, what we can't, and why the truth is way more interesting than the myths. Let's rewind. Humans didn't wake up one day and say, let's hack the sky. This started with a very human problem: uncertainty. Droughts ruin crops. Fog shuts down airports. Hail destroys cities. As climate change increases extremes, the question shifted from prediction to adaptation. Not can we stop the weather, but can we slightly nudge it? That question launched decades of real, peer-reviewed research and some surprisingly practical tools. Let's start with the famous one: cloud seeding. No, it does not create clouds out of nothing. It only works if clouds already exist. Think of it like this: a cloud is a room full of tiny water droplets that want to become rain, but need a reason to stick together. Cloud seeding adds microscopic particles, most commonly silver iodide, agi, or hygroscopic salts, like sodium chloride. These particles act like social connectors. More precisely, ice nuclei in supercooled clouds. They give droplets something to gather around. Collisions increase. Droplets grow. Gravity finally wins. The result? A higher probability of rainfall. Not a guarantee. Under the right conditions, studies summarized by the World Meteorological Organization show typical increases of about 5 to 15%. This isn't theoretical. China's National Weather Modification Program reported similar gains during operations around 2020. And in the UAE, the Dubai Rainfall Enhancement Program continues to fund and test seeding techniques to improve water security. Not magic, just physics, patience, and a lot of atmospheric cooperation. Now, here's a quieter, very practical use: fog dispersal. Some major airports have used targeted methods, like dry ice, solid CO, or silver iodide seeding. Too thin fog, just enough for safe landings. This has been studied and applied in places like Heathrow. Not citywide, not permanent, just hyperlocal, short-term microclimate influence. And this is a recurring theme in climate engineering. Local effects, temporary impact, strict limits. The atmosphere isn't a control panel. It's more like a stubborn negotiation partner. Now, we move into the experimental zone: atmospheric ionization. The idea is simple. The atmosphere is full of charged particles. If you influence those charges, you might affect how aerosols cluster and how clouds evolve. Experiments, including field studies linked to the University of Reading, have observed cloud thickening and even localized increases in daily rainfall. In some isolated cases, up to around 20 to 25%. But here's the catch: these effects are not reliably replicable at scale. Sometimes they appear, sometimes they vanish. Why? Because the atmosphere is a nonlinear system. Think of the butterfly effect. A tiny change can fade into nothing, or cascade into something much larger. Bad unpredictability is why ionization remains research, not infrastructure. Real science includes ambiguity and published skepticism. This one sounds fake, but it's very real. In European labs, researchers have fired ultra-short femtosecond laser pulses into humid air. These lasers create thin, ionized filaments, tiny trails of plasma. Along those trails, water molecules cluster more easily. In experiments conducted by teams associated with ETH, Zurich, CNRS in France, and collaborators, scientists observed enhanced condensation when relative humidity exceeded about 70%. Published in journals like Nature Communications and Physical Review Letters. The results show something subtle but important. The atmosphere responds to energy inputs, not storms, not rain on demand, but measurable microscale changes. Early science, carefully bounded, very far from a weather remote control. Here's the detail that flips the whole story. The biggest limitation isn't technology, it's chaos. The atmosphere is a nonlinear, chaotic system. You don't command it, you influence probabilities. That's why, as the World Meteorological Organization explicitly warns, weather modification effects are probabilistic, not deterministic. You don't make rain. You tilt the odds, and nature decides the rest. This is why large-scale control remains impossible. And why serious scientists are cautious. Not because the tools are powerful, but because expectations are dangerous. Climate engineering isn't about domination, it's about adaptation. Small tools, local impact, careful ethics. There are real risks. Possible downwind effects, where enhancing rain in one area may reduce it in another. Environmental concerns about long-term silver iodide accumulation, and political risks, who decides where rain should fall. That's why international agreements like the UN ENMOD Convention exist. To prevent hostile or reckless environmental modification, used responsibly, these tools sit alongside emissions reduction, conservation, and resilience planning, never as a replacement. The real danger isn't the science, it's misunderstanding it, because when people believe humans control the weather, they stop respecting how fragile the system really is. The future here isn't dramatic, it's cautious, incremental, and deeply human. Hey, appreciate you staying all the way through. Enjoyed it? Smash like, subscribe, and ring the bell so you never miss a new fact. And don't stop now, there's a whole universe of videos waiting for you. See you next time.